Hello, my name is Matt and welcome to my electronics channel. So today I'm going to be talking about the project that I've been tinkering with for the last couple months, which is implementing an RPN calculator on this PicoCalc hardware. And the language that I chose for that is TinyGo. So those are three pretty deep topics that I could talk about for a long time. So this video, I'm not sure what brought you to this video. So I'm just going to do a high-level demo overview of each of these three things: the calculator, the software that I wrote for it, and TinyGo. And if you are more interested, I have a write-up in the description that not only talks about everything in a lot more detail, but also shares all of the code that I wrote for the calculator. And you don't need a PicoCalc to run it. You can actually just run it right on your PC for free, or you can put it on a breadboard for less than $20 with a Pico and make your own DIY type hardware setup. So let's get started by taking a closer look at the calculator hardware. So as soon as I saw this thing, I knew that I wanted it because it looks pretty cool. And I thought, yeah, you can put a regular old Pico in there that only costs a few bucks, and I use those for a lot of other projects. For example, the last one I did was a macro focusing rail, which I have a video on. But I thought, wouldn't it be nice if you're starting a project and you want to have a screen, an LCD screen, and a keyboard, and some GPIOs, if you could just pop a Pico in and get a nice quick head start. So that was my thinking that initially caused me to order this thing. And then while it was taking some time getting to me, I decided my first project would be an RPN calculator. So here I have the RPN calculator that I used in college, which actually still works. So you can turn it on and you can see that it works fine. And I wanted a modern version of this, and I thought, wow, this hardware looks like it'd be pretty good for that. So as you can see, we have a calculator that fires right up and can do similar type graphing and programming and stuff like that. We'll go into that a little later, but that was the main motivation. Okay, so here we are on the PicoCalc product page. I think the product page is pretty cool because it actually digs into the hardware a bit. So here's what it looks like with the cover off. So you just slot in a Pico or other chips that are similar, and moving down a little bit here, we have things labeled. So there's two 18650 battery compartments that you can either use one or two batteries because they're connected in parallel, and the batteries basically last forever. It's got a SD card slot. It has a STM32 coprocessor chip, and on the side here you get some GPIOs that connect to both chips. So if you want to do some quick electronic projects, they're there for you. It's got a couple of speakers with a volume control. And I'll say that the keyboard itself is illuminated if you want it to be. There's also 8 megs of PS RAM, which I haven't quite figured out how to use effectively yet. Oh, and there's also a headphone jack, which I am discovering live here. Scroll down a little bit here, and we can look at the LCD a bit. It's 320 by 320, full color, IPS, and it uses an SPI interface, which makes it easy-ish to program, but the update rate is not very fast if you want to do full screen updates. Probably 15 frames per second would be the max, I would guess. I haven't confirmed that, but that's about what I'm seeing. But you can also do partial updates because it has a controller, so you can get higher than 15 frames per second if you're clever with your updates and only update part of the screen. So as far as the connection, yes, you can put in a Pico or a Pico 2 or a Pico wireless or a Pico 2 wireless. People have also put in other chips that are Pico compatible, but have slightly higher specs. And if you look at the Pico forums, somebody actually figured out how to put a Raspberry Pi Zero in here by creating a custom board that remaps the pins. And with that, they were able to run things like Linux. I think that's a pretty interesting idea. I don't think I would go for that for this because there's no trackball. The screen resolution is a bit on the low side, and the Raspberry Pi regular has the downside where getting it to boot up in maybe less than 10 seconds is actually quite a challenge. Where with Pi Pico, you can boot up in under a second with very little effort. So now I'm going to talk about the pros and cons of the PicoCalc from my perspective. First, the pros. I think the build quality is quite nice. I like the click of the keyboard. I like the way the keyboard is laid out. I like having these arrows up here. I like that it has a light up keyboard for dimmer environments. I think the screen is a good choice for the Pico itself, the amount of power that it has. And I think that if you want to do a project where you want a screen and a keyboard either for initial debug or the final product, it's just a great way to get started. And I can't think of any competitors to this in terms of alternate solutions other than DIY, of course. So on to cons. The first one I'll talk about is the LCD screen. The way that it's installed is just a fit in some tiny grooves. And when I did it the first time, I ended up cracking the screen. I didn't even realize I cracked the screen, but when I put it all together and turned on the screen, it was cracked. And then I looked it up on the forums, and apparently it's a common problem. And the solution recommended on the forums, which I have done now, is to take some electrical tape just to hold the screen in place so it doesn't shift around. The second issue is the Pico itself is a push-in. I think it would be nice if it had levers for clamping it down, again, so that when you're pushing down, you don't risk flexing the board and putting strain on the screen. The other thing is, as you can see, I've kind of hacked up the back here with a drill and a Dremel so I could get to the boot select button, which is needed for programming it. And I also added a reset button, and there's some pins here. I think that it would have been nice if, for the Pico 2 perhaps, PicoCalc 2, they could give you something like this here so that I could just get to the board more easily. Of course, I could do it myself with a CNC machine and a 3D printer, which I probably will do, but it'd be nice if it was already done. Another thing is there's actually a bug in the hardware. So these two, there's a micro and a mini USB. You need the micro to program it, but if you program it with the micro and turn it on with the batteries on, it just gives 5 volts to the batteries, which is a safety issue and a hardware bug. If you use the USB-C, then it charges the batteries. It charges them properly, but you can't program it that way. And also it pulls quite a bit of current. So my suggestion, if you are plugging this thing into a computer, just take the batteries out. And I think that's probably about it. I like a lot of other things. The other thing I like is these are standard M3 bolts, and they actually screw into brass inserts, which is a nod to quality that I appreciate, since a lot of products these days cheap out and have you screwing into plastic. All right, so I'm going to give a little demonstration of the calculator. So we turn it on and you can see it fires right up. So this is an RPN calculator, which was popular in the 70s through the 90s. Some people like myself still use it today. But the way it works is there's a stack that you can put numbers on. So I just put a number 2 and a number 3 on there. And then you can do operators like plus that take numbers off the stack and replace it with something else. So there I just added 2 numbers together. So you can do it in individual lines like that, or you can do it all in one line like that, which is nice because there's a command history. There's also number bases. So let's say you're looking at a spec sheet for a chip and you know you have that in binary and you want to look at it in hex or as a decimal number. And you can add different bases together if you'd like, or do other operations like and or. There's conversions. So let's say I want to see how many miles are in a 5K. And you can see there's also an annotation there. So here it says miles. You can annotate anything. Like let's say I want 40 burgers. And you can see it just puts it in the stack. So that's useful if you just want to keep track of what different numbers are for. So there's different views. So here I am looking at like a terminal-like view in a stack. You can also look at just the terminal, or you can look at it with graph, or there is, I'm trying to remember which, there's a view that shows all your variables as well. Let's do some plotting. So here I'm just going to plot square. So it just takes a range of numbers and puts it into the square function and then plots it. So there we're plotting square. We can add pi t to it. So we'll just take the variable pi, multiply, sine, plot, and that added a sine to it. And of course, you can zoom in to different parts of the graph and stuff like that, but for the sake of time, you can just trust me that that is all possible. Okay. There's code that you can run. So there's a little file system. So here's some different programs I have on there. So we'll pick that bouncing ball one, which is kind of interesting because it shows animation. So you can use tab to complete a lot of things. You can complete variables and command names and things like that. So there I completed the file name, loaded the program, and now I'm going to use tab again to actually execute the function. So here you can see the ball bouncing around on the screen. Okay. And we'll just Control C out of that to quit. Okay. Now, let's take a look at that program because there's a built-in editor that you can use. And we're not going to go through exactly how it works, but you can see it's not Go code, it's actually RPN commands with things like for and if and conditionals added on so that you can implement code. So that's how all that works. And then the only last thing that I'll show here is there's save state. So let's say that I am in the middle of doing something. I don't know. X squared and x cubed. Okay, and then I want to take a break and come back to this later. You can actually hit F4 because that's the way I have it set up, and it'll record a snapshot to disk. And the snapshot itself is just a bunch of commands. So you can actually load it into an editor and edit it if you want. But the point here is now that it's been saved, I can shut the calculator off, come back sometime later, and load in that snapshot and continue where I left off. So that's probably most of what I want to talk about. The only other thing I'll say is there's built-in help. So here's all the different things that you can do. And if you're interested in learning about a particular command, then you can type it with a question mark and it will give you a bunch of help on that command. So that's a basic rundown of what the calculator can do, and it's all open source, written in Go, so if you want to expand on it or add your own functions, you can. And it'll also run on other platforms like the PC, which I'll demonstrate real quick. All right, so I'm going to give a quick demo on the PC here. So this is an N curses version, which means it's all text and you can run it through a terminal. It'll run on basically any PC, including Raspberry Pi regulars. It can also be run on a breadboard. I'm not going to live demo that here, but I'll just throw up a quick pic of what that would look like. But anyway, let's just run it. So you can see it comes up quick and it works just like the PicoCalc. So here I added 2 numbers. Here I did a plot. You can see it does it in the N curses window. If you wanted to make it graphical, you could use, I don't have a graphical version written for the PC yet, but it would be straightforward to do so with Qt or WebKit or SDL or something like that. Here's the good old bounce ball demo. Quit out of that. And here is what I think looks kind of cool, a spiral, animated spiral. So yeah, that's it for that. So to wrap up, we'll just look at the code a bit and TinyGo itself. So let's go to the TinyGo website. So you just type TinyGo and this is it. So you can just say get started and you can go through an install guide, a tour, an overview. Somewhere it tells you how many chips it runs on. Maybe in documentation here. There we go. So it runs on a lot of microcontrollers, as you can see. Although I don't think that the support for all these microcontrollers is at the same level. I know that the PiPico is supported quite well. And there's also kind of interesting a WebAssembly version, which could be kind of cool to play with. So I could potentially run the calculator in a web browser, which I want to play with it sometime. And then to learn Go itself, you can say tour of Go. So Go is a language that's used a lot in infrastructure and tooling. So like, for example, Docker and Kubernetes and stuff like that is written in Go. And getting onto the project itself, I have a project on GitHub. It's called RPN Go, and there's the URL there. And yeah, here's all the code. Here's a quick tour of what it is. And then beyond that, I have a user's guide, which goes through all of the features and how to do everything, basically. So you can go through and look at this if you want to dig into how the calculator works. Okay, I'm going to talk just for a minute about TinyGo pros and cons. A big pro is that you get to code in Go, and I think Go is a great language to learn. A lot of code that I used to write in Python and Java, I now go for Go because I think it's simple yet powerful. I like its structures, its interfaces, its type system. To keep it brief, I'll just say that I've been coding for a few decades and I think it's good. As far as TinyGo specifically, Go itself uses heap memory implicitly, which means it tries to use the stack. And if you're careful, you can get it to use the stack, but it can also use the heap, and it can be subtle when that happens. And using the heap can be a problem because microcontrollers don't have a lot of memory. For example, the Pico itself has only 264K. TinyGo compounds the issue by not moving blocks in the heap once they're allocated, which means the heap can get fragmented, which means you might need to allocate a block and there's enough total memory, but it still fails because there isn't enough contiguous memory. That moves on to problem number 2 I'll talk about, which is I think the panic trapping recovery for TinyGo could be more robust. I was having a lot of trouble catching panics, because if you run out of memory, it would be nice if you could catch that and try to recover manually in your code, but I was having trouble doing that. So instead I'm using the watchdog timer, which works okay, but it's nice to have more options. And then the final thing I'll talk about is maturity. Having a mature ecosystem for a platform, it takes a long time and a lot of work. And I think TinyGo is a bit behind things like Arduino and the Pico SDK in that area. You can open bugs and they're pretty responsive, but just note that you might run into more issues just in day-to-day trying to get things done. So to sum things up, I would say it's great for experimentation. It's a lot of fun to play with. But if you're writing something big, something serious, or something you might want to charge for, I would tread carefully. All right, that's a wrap. So I hope you enjoyed the video and learned a few things about the PicoCalc and TinyGo. And if you have any questions or comments, corrections, encouragement, discouragement, please feel free to leave a comment. Feel free to leave a like. And I hope you enjoy the rest of your day. Thanks.